Railway maintenance is more than a practice. It provides the backbone of the system for a reliable and safe rail. As railway networks expand and modernize, efficient and effective maintenance has never been more important. Each of the many types of railway maintenance, from preventive to predictive, serves a unique purpose. Still, all are related in the way they strive towards quite similar goals, reducing the chances of downtime while increasing both safety and lifespan. Hello, welcome to Search Pulse. Today, through this video, we will explain different types of railway maintenance, including what each does, how it is performed, and some of the most recent technologies powering them. Whether you are a seasoned practitioner in the field or interested in the minute details of railway maintenance, this would build a comprehensive understanding for professionals as well as the general reader. Understanding these methods gives us an insight into the depth these maintenance strategies go into keeping railways running smoothly. But what is the importance of railway maintenance? Railway maintenance represents the backbone of safe, reliable, and efficient rail operations. Scheduled maintenance is meant to ensure uninterrupted operations of trains and infrastructure, and it largely enables its objective since failure to observe such a practice results in real accidents, increased costs, and shortens life of railway assets. The importance can be understood from 3 points: safety, economics, and infrastructure durability. Safety is the number one priority of railway operations, and maintenance is the keystone to ensure both now and in future for cargo and passengers. This is important in identifying and rectifying potential hazards before they get out of hand. For instance, routine track maintenance averts accidents caused by derailment by identifying the track wear, misalignment, and structural weaknesses. Besides averting accidents, regular maintenance will also improve the overall reliability of rail services. Trains can run punctually, and the passengers do not encounter many failures. This reliability is important not only for passenger safety but also for the whole rail's operational efficiency. In economic terms, it is a way of avoiding expensive breakages and repairs. Preventive maintenance involves periodic minor repairs after minor inspection. These are way cheaper than corrective maintenance done after a failure. Proper investment in regular maintenance will help the rail operators avoid immense expenses related to emergency repair work, disruption of services, and even possible liabilities in case accidents occur. A good railway is one that will run more efficiently using less fuel, with reduced wear on rolling stock, which again will bring greater savings still in the long run because of its efficient maintenance practice. Railway infrastructure, which includes track, bridges, tunnels, and signaling system, is an investment worth a lot. This means there is a need for regular maintenance to protect and extend such an investment. Maintenance activities extend life of these various assets in many ways, such as handling minor issues that might later become a major and hence very expensive in replacement. This will save money in the long term and help make the railways more sustainable through reduced consumption of new material and reduced construction process. Now we know the importance of rail maintenance. Now let's see what are the maintenance strategies and approaches. Effective railway maintenance means more than routine inspection and repairs performed. It involves strategic planning and acts through varied approaches to maintenance that optimize activities for assured safety, reliability, and cost efficiency. Thus, strategies are adopted vis-a-vis the needs of the railway network and the condition of assets with the help of available resources. It will bring out some of the established strategies and approaches in maintenance, such as total quality maintenance, risk based maintenance, and reliability centered maintenance, which are very important in ensuring the integrity and performance of railway systems. The total quality maintenance or TQM in railway maintenance consists of regular checks on the practices of maintenance, standardized procedures, and all the stakeholder concerned from the maintenance crew to management in continuous improvement. Through a quality improvement culture, TQM reduces the rate of errors, enhances efficiency, and ensures that maintenance activities are done and maintained at the highest standards possible. In addition, TQM also encourages the proactive identification of possible problems to fix them before they become significant issues for the rail operators. Risk based maintenance is a strategy that allocates maintenance resources based on risk assessment results related to equipment failure. This helps the rail operator apply maintenance resources proportionally to the degree of risk resulting from failure of certain components or systems. In a practical sense, RBM means identifying the likelihood, in particular, and consequence of varied failure scenarios and then formulating maintenance plans that mitigate the riskiest. For example, suppose a section of a given track will likely fail because of its age or exposure to environmental condition. In that case, RBM will prioritize this over less important areas. This directed approach ensures the focus of maintenance in areas that are correspondingly high priority for both safety and cost effectiveness, thereby keeping interruption in rail services down to a safe minimum. Finally, reliability centric maintenance or RCM is a maintenance strategy that ensures railway systems are maintained at an optimized level of reliability. RCM entails analyzing the component's function, their possible ways of failure, and the effective maintenance tasks that reduce the risk of such failure. It finds special application in the railway industry, where the reliability of critical systems is crucial to safe and efficient operation. RCM prioritizes maintenance activities by impacting the system's reliability, ensuring the most critical components get attention. With a focus on reliability, RCM has the advantage of improving railway systems, performance, and reduced maintenance cost by avoiding non relevant tasks and increasing scheduled activity interval. Now we know the strategies adopted by railways for maintenance. Let's see the six types of railway maintenance activities. Railway maintenance is all the activities that help to ensure the railway network's safety, efficiency, and life expectancy. These activities can be broadly classified under maintenance types with certain objectives, methods, and application. Understanding these types of maintenance is important for professionals in this field and general public who need to know how trains keep running and how the underlying infrastructure is kept in a good condition. Here we will learn the major types of railway maintenance activities like routine, emergency, corrective, preventive, predictive, and condition based maintenance, noticing their peculiar role and importance. Routine maintenance is comprised of typical routine tasks that are performed to keep the railroad infrastructure operational. While these tasks are more frequent, they tend to be less complex, yet no less important for restoring basic functionality and preventing small issues from occurring enough to develop into catastrophic failure. Some examples include routine daily track inspection, ensuring lubrication systems are full and operational by checking and refilling lubricants, clearing vegetation and other debris from the right of way, and making small adjustment to equipments. Although routine maintenance is quite mundane in appearance, it is extremely important to the general health of the railway network. It ensures that more major efforts at maintenance do not become commonplace too early. Emergency railway maintenance is the most urgent kind of maintenance. It is conducted in response to critical failures or hazards posing immediate risk to safety and operations. Emergency maintenance is often unplanned and calls for rapid resource mobilization to address problems caused by derailment, considerable track damage, or major signaling failure. The most critical goal of emergency maintenance is to restore normal, safe operations as quickly as possible. It implies that besides repairing the immediate problem, some serious investigation needs to be done to ensure that the initial failure has introduced no secondary problems. Emergency maintenance is challenging because it is unpredictable and high stakes, making it very important that maintenance teams are well prepared with robust response strategies and resources at their command. Corrective maintenance is often dubbed as reactive maintenance because maintenance and repairs are undertaken only after the fault or failure occurs. Corrective maintenance works in a manner to bring the railway system back to working order after an issue has already occurred. This type of work is more immediate. It will include major repairs such as rail replacement, signal work, and rolling stock repair. This would make remedial maintenance procedures vital in addressing those unpredictable problems that will occur despite such preventive action. It is costlier and more time consuming. Still, it is an integral part of the total railway maintenance strategy that ensures effective problem solving within a short period, preventing time loss, saving well, and keeping operations safe. Preventive maintenance is a proactive approach directed at a periodic inspection and routine activities to avoid possible failures before they occur. This type of maintenance is scheduled by setting a time interval or condition, such as counting the average number of trains that have traveled over a certain portion of the track. The goal is to find and correct wear and minor failures before they cause more serious problems. Some common activities for preventive maintenance include inspection of tracks, lubrication of movable parts, tightening bolts, and cleaning components. A proper preventive maintenance strategy can avoid the corrective maintenance work, improving reliability, avoiding downtime, and reducing cost of maintenance work. Predictive maintenance is a data driven philosophy of railway maintenance driven by advanced technologies that can predict component failure. Such data, which emanates from various devices including sensors, IoT devices, and condition monitoring systems, is analyzed to enable maintenance teams to recognize the pattern of impending failures and accordingly schedule maintenance activities. Some technologies deployed in preventive maintenance include vibration analysis, thermal imaging, and acoustic monitoring, which track the condition of critical components in real time. For example, vibration sensors fitted on a bogie or wheel shaft may point out problems in gearbox, traction motor, or bogie frame, allowing the maintenance teams to intervene before failure occurs. Predictive maintenance optimizes planning for maintenance, reduces too much unnecessary maintenance work, and minimizes railway service disruption. Although condition based maintenance may seem very close to predictive, it uses real time data to establish equipment condition assessment. The data is captured on the onboard TCMS of the train, or it will be relayed to a remote data server where the inbuilt algorithm can perform the analytics of the data on real time basis, giving necessary indication of the condition of the train. It sets out to perform actual maintenance only when the predefined indicators show that the component's condition deteriorates beyond the acceptable limits. It is far more focused than preventive maintenance and more immediate than predictive maintenance, as it responds directly to the real state of the equipment and does not rely on times of predicted failure. For example, if the wear level for the track exceeds a predefined threshold, then the condition based maintenance would trigger an immediate repair. This enables effective use of maintenance resources by performing maintenance precisely at the right time, neither under nor over maintaining any asset. Alright, so far we have understood the importance of maintenance, strategies of maintenance, and types of maintenance work. Now let us understand the techniques applied in railway maintenance. Improvements in tools and techniques have drastically changed the nature of railway maintenance. Now, the railway maintenance fully uses the latest equipment and digital technologies to develop efficiency, accuracy, and safety. Those tools and technologies help systematization, but also more sophisticated approaches to predictive and condition based maintenance for traditional maintenance activities. Modern railway maintenance is comprehensively equipped with many high precision and efficiency-oriented tools for carrying out tasks. These range from simple hand tools to high-end specific equipments attuned to execute specialized maintenance tasks. For instance, rail grinders are applied to renew the correct rail profile by removing minor defects and wear, thus extending the life of tracks. Another important device is the ultrasonic testing device, which enables a maintenance team to discover internal flaws within the rail, such as cracks or voids that the naked eye cannot see. The track geometry measurement system mounted on dedicated inspection vehicles deliver detailed data regarding track alignment, gauge, and elevation to make timely interventions for the integrity of tracks. These tools allow maintenance to be performed correctly, thus reducing human error and raising the general safety level for rail operations. The last few years have seen how technology innovations now include advanced systems that upend productive power in monitoring and analysis, changing the decision making process, all linked to railway maintenance. These technologies include sensors, drones, and automated systems for real time data with relevant comments. For example, the progressive use of IoT devices in the railway maintenance sector provides room for monitoring critical components such as tracks, switches, and rolling stock conditions. The sensors collect information regarding parameters that include temperature, vibration, and pressure, which are analyzed to predict possible failures before they happen. Drones with high resolution cameras and LiDAR can work from sky, acquiring detailed imagery of tracks, bridges, and other infrastructure while giving informatics from areas that are impossible or not visible without exposure to operations. This new technology has greatly improved efficiency and safety in railway maintenance. For instance, predictive maintenance systems that use data from IoT sensors can accurately predict when components are likely to fail, reducing the need for scheduled maintenance. This saves time and resources and minimizes service disruptions, keeping trains running on time and tracks safely. Another application is the inspection vehicles equipped with sensors and cameras that can quickly cover large areas of railway network, identifying irregularities such as rail defects and vegetation encroachment. Machine learning algorithms then analyze the data collected to prioritize maintenance tasks based on severity and potential impacts on the issues found. So we know the techniques applied in railways for maintenance work, but does everything runs perfectly well? Despite the many developments in tools, technologies, and maintenance strategies, railway maintenance still needs to be challenged on aspects affecting rail operations, safety, efficiency, and cost effectiveness. One of the main challenges is the aging infrastructure, typical of many rail networks worldwide. While the tracks, bridges, and other key components keep aging, they require more frequent and intensive maintenance, straining resources and leading to increased downtime. Another major problem is related to the fact that railway infrastructure is normally exposed to very aggressive environmental conditions. Serious damages could be caused by extreme temperatures, torrential rainfall, and natural catastrophes such as flood and landslides. This can be the source of critical damage to tracks and other equipments, entailing urgent and most expensive repairs. Some railway lines are far from inhabited places, so maintenance is much more complicated as special equipments and time for certain tasks are needed. Resource constraints such as budget and well trained maintenance personnel also add to the complexity of railway maintenance. Indeed, as railway networks are extended and modernized, the demand for maintenance increases. But the resources to match this demand are not always available, leading to deferred maintenance that could increase the risk of failures and accidents. Finally, the need for constant maintenance and the least possible disruption of rail services conflict constantly. Maintenance activities should be planned and coordinated with the scheduled train times in advance to avoid delays, especially on busy rail networks where a small amount of downtime may lead to an enormous delays and financial losses. To conclude, railway maintenance is an intricate and vital component of ensuring rail networks' safety, reliability, and longevity. Rail operators can better manage their infrastructure and optimize their resources by understanding the different maintenance types, from preventive and corrective to predictive and condition based. Adopting advanced tools and technologies alongside strategic approaches like TQM, RCM, and RBM further enhances the efficiency and effectiveness of maintenance efforts. Despite the challenges such as aging infrastructure and environmental conditions, continuous innovation and strategic planning are the key to overcome these obstacles. Effective railway maintenance is essential for smooth operation of rail systems, contributing to passenger safety and satisfaction and the rail industry's overall sustainability. If you have made this far, then please click on the like button, give your valuable comments, and subscribe to this channel. Thanks a lot.